Hello and welcome to the Habitat States webinar as part of our Grizzly Bear Tools webinar series. My name is Cam McClelland. I'm a senior biologist for the Grizzly Bear Monitoring Project. Today I'll be going through what the Habitat States tools do, how to run them, and then we'll get into some interpretation of the results. So just to go back through what Grizzly Bear tools do, grizzly bears rely on their habitat to provide three essentials for life. The first is resources such as food and water, security to prevent excessive rates of mortality, and mobility to allow dispersal into new territory and maintain genetic diversity. For the grizzly bear tools, we developed spatial models to predict all three of these attributes with the goal to support and inform long-term survival of grizzly bears and their habitats in Alberta. And our goals are to preserve high quality habitat and reduce mortality risk, forecast the effects of development, and compare the relative impacts of multiple scenarios. When we run GBTools, we need to use ArcGIS Pro program as they are a toolbox within this. And the tool set consists of base spatial data representing model predictor variables, geoprocessing scripts written in Python 3, and an ArcGIS Pro toolbox, which contains all the graphical user faces or GUIs to run each script. Before we get into running these tools, I just wanted to chat about the tool spatial layers. So layers within the tools are from 2021. This is based on the most recent ABMI human disturbance layers. And we update these layers based on when these layers are released. However, ABMI layers lag by about 2 to 3 years. So when we do get that new ABMI layer, human disturbance, which includes cut blocks, seismic lines, and roads, we then update our land cover layers respectively. And it is also important to note that the date of these layers, so 2021, needs to be considered during interpretation. So when you run this, it's running it for 2021 and not for 2024. So the results may be out of date by 3 years, and that needs to be considered when you are looking at these results. Another note is that the canopy cover and percent conifer layers are from 2018. This is because these are the most up-to-date layers that we could get. More up-to-date layers are too coarse, but we are continuing to search for an alternative to these layers so that we can have them as up-to-date as possible. So just to go into what tools we have at our disposal, we have our roads tools, we have a Denning RSF tool, we have our Habitat States tool, and we have a Siteability tool. Today, we're going to be going through our Habitat States tools. So there are three main aspects of the Habitat States tools. We have our resource selection functions, our risk layers, and our Habitat States layers. Our first habitat tool is our RSF tool. RSF stands for Resource Selection Function, and higher values of RSF equal higher probability that grizzly bears will use that area. RSF is modeled from GPS collar locations and 6 forest, terrain, and landscape variables. However, RSF does not model where bears are on the landscape, just where bears are more likely to be. Bears may still be present in areas of low RSF. It is important to note that our RSF maps match the distribution of bears from our DNA inventories. Looking at this map here, we can see that our higher RSF values are in blue and our lower RSF values are in red. Our higher RSF areas include the Front Range of the Rockies and along valley bottoms. Lower RSF values include mountain peaks and as we go further east. Our next tool is our risk tool. The risk tool predicts the probability of grizzly bear mortality and models this using landscape variables. On the right here, we have a figure depicting mortalities of grizzly bears by time spent in areas of higher mortality risk. Up here, we have time spent as 2 to 4 years, 1 year, and 1 week. You will see that bears that spend more time in risky areas have lower mortality risks than bears that spend less time in risky areas, as they are more used to the risk. However, on a whole, grizzlies that spend more time in risky areas have a significantly higher chance of dying than those that don't. It is important to note that areas of high mortality risk can include areas of high RSF values. Risk models are generally based on landscape and anthropogenic variables. Anthropogenic variables include proximity to roads, trails, agricultural areas, and protected areas. Over here, you see that within the mountains, we have relatively low risk to those areas that are east of the mountains and into the foothills. The Habitat States tool is a different way of looking at RSF and risk, combining both tools into one and simplifying them. Habitat represents areas of low risk of mortality and high RSF values. Sinks represent areas with high risk of mortality and high RSF values, and then track bears into areas with high risk of mortality. We want to reduce sinks and increase habitat for bears. On the map here, you can see that habitat lies mainly in the mountains and along the first bit of the foothills, whereas sinks lie along this area of the foothills with a large amount of anthropogenic development and a large amount of human use. Let's go over what BMAs and over what seasons we have our risk and RSF models for. So we've developed seasonal models for 3 seasons for 6 population units. We have the Livingston Castle models, which combines BMI 5 and BMA 6. We have the Clearwater model, which is BMA 4, the Yellowhead model, which is BMA 3, the Grand Cache model, which is BMA 2, and the Swan Hills model, which is BMA 7. We have developed these for 3 seasons. So the first season is spring or hypophagia, which begins from den emergence and ends June 14th. We have season 2, which is summer or early hyperphagia, which begins June 15th and ends August 7th. And then we have the third season, which is fall or late hyperphagia, which begins August 8th and ends with denning. Our Habitat States tool regenerates the grizzly bear RSF risk and habitat states model. The habitat states model is created by combining RSF and mortality risk models from base landscape layers. The tool can incorporate 5 types of anthropogenic changes, including openings such as harvests and wildfires, roads, pipelines, habitat deletions such as mines, quarries, urban development, and road reclamation, along with being able to forecast conditions up to 40 years post-disturbance by simulating canopy growths in regenerating harvest blocks. Okay, so let's get into the thick of it here. The first tool we'll be running is our Habitat States tool, which is the core of our Habitat States tool set. This over here is the Habitat States graphical user interface. And as you can see, when we double click on that within our toolbox, we have 4 required inputs, and then we have some optional inputs and some advanced options. This first input is the landscape conditions, which shows for which year the tool is being run, and this cannot be changed. Our next input is where we're going to put in our folder name where results are going to be written and stored. For the Habitat States models, outputs are saved under our GBTools folder, under our results folder, and then under our Habitat or Hab State folder. Folder names must be unique and must be supplied by the user. Our next input is where we will put in a polygon layer representing the area of interest, or AOI, you wish to analyze. A 1 kilometer buffer is applied to the AOI to account for edge effects during processing. Our third input here is where you specify which population unit you will be running the tools on. We have options including Grand Cache, Swan Hills, Yellowhead, Clearwater, and Livingston Castles. These parameters determine which set of coefficients will be used for your RSF model. So it's important to determine where within which BMA or area your area of interest lies before running the tool. Now let's get into our optional user inputs. So the first one here is our new clearing input. And when we add something into our layer into this input, a couple more options will pop up as we'll go over in our example. But this is where you're going to add your polygon features that represent your new harvest or cleared areas. Adding new clearings here will update the regeneration mask and the crown closure within treed areas to account for the loss of vegetation. When you add in new clearings, you will be asked to define which column contains the clearing year. You will also have an option to forecast ahead to a future year to see how regeneration of your clearings has changed your habitat state's output. Our next option here is our new line features as herb. And this is where we're going to add in our new linear features representing new pipelines, trails, seismic lines, and other features that remain vegetated. New features here will be appended to the trails dataset. And distance to trails and linear features is a predictor for mortality risk. And the new line features are added to the cost distance to trails layer that will be used to generate the risk output for the area of interest. Next, we have an area where we can input our new roads in. So this is where we're going to add our new roads that you may be creating in your area or to update the existing roads layer. These will be appended to the existing roads layer. This distance to roads is a predictor for mortality risk as well, and the new roads are added to the cost distance to roads layer that will be used to generate the risk output for your area of interest. We then have our reclaimed roads, where roads uploaded here will be removed from the existing roads dataset. You can use this to update the roads layer with either reclaimed or gated or even closed roads. And then we have our habitat deletions, and this is a polygon layer that represents areas of habitat removal on the landscape. So these values will be set to 0 or no habitat, and this is meant to represent no habitat such as mines and gravel pits, essentially areas with lots of rock and very little veg. Now let's go into our advanced options for our habitat states tool. So our first advanced option is our delete intermediate data option. This option is to delete all intermediate data to keep output size to a minimum. When checked, all intermediate data, rasters, and feature classes will be deleted. This is the default. And unchecked intermediate data will not be deleted. You may not want to delete intermediate data for bug checking or if you want to keep all your intermediate files, but it is suggested to delete intermediate data. We then have our model selection input, and this is an advanced option to run either the entire script or specific models. The default is the habitat states model, which would run the entire script and give you habitat states, RSF, seasonal RSF, and risk outputs, but you can also just select either one of those. It is good to note that run times can vary depending on the size of your area of interest. We recommend running smaller areas. Large areas will take a significant amount of time to run. For example, running an entire BMA can take up to an hour, maybe more. We also recommend running multiple different scenarios. This is to compare and more easily measure change between your different scenarios. Okay, well, let's see what this process looks like. We are just going to go through an example of how to run the habitat states tool. Okay, let's use the habitat states tool today. So first things first, I've loaded in everything I need to run this into my table of contents. So I've got my planned blocks, my roads for reclamation, my planned roads, my planned seismic lines, the landscape roads, which we actually won't need for the tool. But most importantly, I have my area of interest for which we're going to run the tool over. Um, and that's kind of all we need. So then let's navigate to our tool. So that's in GBTools under our GBTools Pro toolbox and under Habitat States. We'll double click that. And as before, we've got our required inputs, and then we have our optional inputs and our advanced inputs. So let's start with required inputs. The first thing is naming our output folder. This is for where your results are going to appear in. So under your results, under your habitat state or hab state here, your results will appear under this folder name that you put here. So let's just put hab states 1. Now let's put in our area of interest. You can do that from the drop down, or as I prefer, just dragging and dropping it from your table of contents. So put that in there. And then we need to define our population units. So this is based on bear management areas and which bear management area your area of interest falls within. This area of interest is just outside of Nordegg, so so it falls within the Yellowhead bear management area. So I'm going to click the Yellowhead bear management area. Next, let's go to our optional inputs. So clicking this, and we'll just go through the 5 optional inputs we have here. The first one is our new clearings inputs. So this is where you're going to put in your planned cut blocks, planned well sites, anything along that nature. And we can just drag and drop that in here. And you'll notice that when we do that, 2 additional inputs come up. The first is define clearing year. So that's where you're going to go through here and select the column that contains the year that that area was cleared. And then we have our forecast year. So generally it appears as 2021 because that's when our data is from. But if you want to forecast or predict for a year in the future, say this year of 2024, we could change it to 2024, and the habitat states output will reflect regeneration and all that into the year 2024. Next, we have our new line features as herb. So that's seismic lines, pipelines, anything that will appear on the landscape as a herb area and not a road. So I've got some planned seismic lines here that I just drew on the landscape. Coming down here to number 3, we have new roads. So I've got a planned roads layer here that I'm going to add to here. And these are be the planned roads that I'm using for the new cut blocks. We then have a reclaimed roads section where we can put in a shapefile of roads that we want to be reclaimed. So drag and drop that in here, and as you notice, another input comes up. So when they are reclaimed, what do we want them to be reclaimed as? The 3 options are barren, herb, or matched neighbors. Matched neighbors will be matching the nearest neighbors around your roads, or you can select that they'll be barren or herb. We're just going to select herb. The 5th option here is habitat deletions. So this is areas that are taking just habitat off the landscape. So this can be like open pit mines or a gravel pit, anything that will have no value for grizzly bears. I don't really have a layer for this, so we're just going to leave it blank for now. And we'll go on to our advanced options. So click on that. And then you see we have 2 advanced options. The first is our delete intermediate data. I always recommend that this be selected because it cuts down on memory or space to store data, but it can be useful if you want to keep all the steps leading up to the final output. And then we have to select what we want to model. So we can select habitat states, which will give us our habitat states output, our RSF output, or our risk output all in one, or we can select RSF only or risk only. We're going to select habitat states because we want all of our outputs. Okay, so let's run it. Okay, so that's finished running. So we've closed the dialog window and now we can take a look at our results. So as you can see here, the only results that are imported directly into your table of contents when the tool is run is our habitat states output. So our primary sinks are in red, secondary sinks yellow, secondary habitat in light green, and primary habitat in dark green. And as you can see, when we overlay roads, a lot of our primary sinks are near roads and in valley bottoms. And a lot of our primary and secondary habitat is further away from roads and towards the foothills. So on top of our habitat states output, we also have our RSF and risk outputs. And those are stored, those aren't actually added directly to our map in our table of contents after we run the tool. Those are stored under our results. So GBTools results and under habitat states. And then we can go to our run, which was habitat states 1. Open that up. And then you'll see here that we have our raster files, which is the raw raster data, or we have our layer files, which are add all the symbology and everything to the map. We also have some tables here at the bottom. So the best way to add the data to the map is to grab your layer file, layer X file, and drag that into the map. So we'll drag our risk file into the map. We'll drag our risk class into the map, drag our RSF results into the map. And now let's just take a quick look at each of these. So up here we have currently we're viewing our risk. So high risk is 10, low risk is blue. Sorry, high risk is red, low risk is blue. And as you can see, high risk along roads, and the further east we go. Next, we have our risk class. So this is just essentially a simplification of our risk layer, where this bluish greenish color represents our secure habitat and the brown represents our vulnerable habitat. And then we have our RSF results, which all show up when we drag in our RSF results. We get under this main category, we get our RSF max, which is maximum RSF for the area. We have our RSF for spring, summer, and fall. And then we have our RSF class. So RSF max, the lighter colors is our low RSF, darker colors high RSF. And then we have that for each season. And then we have our RSF class, which we can look at overlaying our RSF max layer. And that just shows where our secondary and primary habitat is. Now that we've run our habitat states tool, we can now run our habitat states area plot tool. The area plots tool generates habitat state, RSF, and risk grid cell value areas presented in a bar graph report. The area is calculated using the following equation, which I'm not going to read, but it's here for reference. And essentially, it gives us a bar graph for each of our bin values or values for each RSF, risk, or habitat states. So for RSF, that would be our 1 to 10. For risk, that'd be 0 to 10. And for habitat states, that would be our primary sink or secondary sink, and our primary habitat and secondary habitat. When we navigate to our GBTools Pro toolbox and we double click on our habitat states area plots tool, this is the GUI that pops up. And here we have two inputs. So we have an input where we can navigate to our habitat states folder that you created in your previous habitat states run. This will appear in your results folder under GBTools results, have state, and then whatever you named your folder. And then a panel will pop up where we are able to select which option you want to run this for. So you can select habitat states, which will run it for all, or you can just run it for RSF, risk, or habitat states individually. So let's see what this process looks like by running through an example. Okay, let's run the Grizzly Bear Tools habitat states area plots tool now. So to get to this, we go to our GBTools folder, and it's under our GBTools Pro toolbox. And then we go to habitat states area plots, and we double click on this. And then, as you can see, two inputs pop up. We have our input habitat states folder. So this is where we're going to navigate to previously run habitat states output. So to get to this, we're going to go to our GB tools folder under results and under hab state. And then we're going to do this for the reference. And so we'll click on that and drag and drop it in here. You can either drag and drop it like I just did from here, or you can browse for it through this. Now, once we do that, a second option pops up, and this is just for what metrics we're going to calculate these for. So we want, you can choose a habitat state, risk, RSF max, or one of the seasonal RSF layers. We're going to do it for all three of habitat states, risk, and RSF max. All right, so that's all we need to do. Let's run it. And once we run it, we see that these area plots automatically pop up for us. But if they weren't to pop up, let me just show you where to find them. So these, for me, are under my documents, under my GB tools folder. And then once we get in there, we navigate to our results, to our habitat states, to our habitat states reference, this is the folder we ran it on. And then under here, it'll be under area plots. All right, so that's where it is. I'm just going to go back to the plots now, and we can go through them. So we have area plot for RSF max, risk, and habitat states. Let's start with RSF max. So we have our RSF values 1 to 10, 1 being low, 10 being high. And we have the area in kilometers squared that each of these values takes up in our area of interest. So for 10, for example, it takes up 37 kilometers squared. 1 takes up 7.5 kilometers squared. We see that the majority of our area, the RSFs are contained within 5, 6, 7, and 8, which is pretty good. So on the higher end for sure. So that's that. And this is just a good way to look at the proportion of your area that each bin takes up. Same thing for risk. 0 risk is non-grizzly bear habitat. 1 is less risky habitat. 10 is very high risky habitat. You can see that 1 is our largest bin, so we have not very much risky habitat in this area, which is very good. Now let's look at our habitat states plot. So our -2 is our primary sink. Our -1 is our secondary sink. Our 0 is our non-critical habitat. 1 is our secondary habitat, and 2 is our primary habitat. And as you can see in this area, we actually have quite good distribution where we have a lot of secondary and primary habitat and not so much primary and secondary sink. And again, this just shows you exactly how much each of these are in kilometers squared within our area of interest. Our final habitat states tool is our change detection tool. The change detection tool generates habitat state, RSF, and risk change detection image reports comparing 2 previous habitat states runs. It also provides us with spatial layers that determine where this change takes place. One run will be considered the reference run, and the second run to compare is considered the scenario run. The area and percentage change between each respective value is captured in a grouped bar plot, and an overall percent change to the landscape is calculated. Areas of positive or negative change are then mapped in a spatial layer. So when we navigate to our habitat states change detection tool within our GBTools Pro toolbox, this is the graphical user interface that pops up. And as you can see, we have 5 input options. The first input is the reference habitat states folder. This is where you're going to navigate to the folder that holds an output generated from a previous habitat states run. And this is the run that you want to consider as your reference. These rasters will be compared against our scenario rasters. This next input is where you're going to type in the name that describes your reference data. Your description must be 10 characters or less for display purposes, and this is what will be displayed on your area plots. This next input is where we'll input the scenario habitat states folder. So navigate to the folder that holds outputs generated from a previous habitat states run. This folder should contain rasters that you want to consider as your scenario rasters, and these rasters will be compared against our reference rasters. Our next input is similar to our name reference data, and this is where you're going to type in a name that describes your scenario data. Again, the description must be 10 characters or less for display purposes, and this will be displayed upon our change detection plots. Our final input here is where we'll select which habitat state output rasters you want to compare. So this is where we'll input which rasters you want to compare, and our choices are habitat states, risk, or RSF max, or our seasonal RSFs. So let's see what this process looks like. We're now going to go through an example of how to run this tool. Okay, now let's run our habitat states change detection tool. In order to run this tool, first we have to have run our habitat states tool twice. One as our reference, so generally you would just run this on the base inputs and not add any rows or cut blocks or seismic lines or anything to that. And then we have our scenario, which is where we have added our new cut blocks, our new roads, our new cut lines, etc. So I ran it twice. Now I want to navigate to the habitat states tool. So I'm going to go to my Grizzly Bear tools, go to my GBTools Pro toolbox, click on that, and then we're going to open up this habitat states change detection tool. You'll see that we have 5 inputs here. The first is where we're going to import our reference data. So you can either navigate it to it from here on this browse icon, or you can just drag and drop it from your catalog. I'm going to do the latter, which is going to results under your habitat states results. And then I have it named here habitat states reference. I'm just going to drag and drop that over there. I'm going to name it reference. Here, that's just, you just need to name your reference data. I'm just going to name it reference. And then we need to do the same thing for scenario data. So I'm going to grab my scenario data from here, drag and drop it over here, and I'm going to name it scenario. Okay, now we select which habitat states outputs we want to compare. So we can choose multiple of these. So I'm going to choose habitat states. I'm going to choose risk, and I'm going to choose RSF max. And so we've chosen all that. Everything looks good. Now let's run the tool. Okay, so we've ran the tool. It ran, it's completed. We can now close down this dialog box. And you'll notice that nothing new has appeared on the map. That's because we have to navigate to our results. So to navigate to our first set of results, we have to go to our File Explorer. And I'll just show you where these are. Already have them open, but so navigate to your Grizzly Bear Tools folder, navigate to your results, to your habitat states results, and then we're going to navigate to our habitat states scenario because that's where they're stored. So click on that. And then we're going to navigate to one of these folders. So I already have one run, but this is my second run in change detection. So I'm going to click on this one, change detection 01. If you only have one run of change detection, it'll just pop up as 00. But every new run gets another number. So I'm just going to double click on this. And then I'm going to go to my percent plots. And then I'm going to open these with photos. And we are. So we have our habitat states plot, our risk plot, and our RSF max plot. In each of these plots, we're comparing area to our categories for each RSF, risk, and habitat states to see how the scenario in green has changed from the reference in red. Over here, for each of these plots, we have the value and the percent change. So this just gives you an idea of how much each of our categories for habitat states, risk, and RSF, the new scenario has increased or decreased each category when compared to the reference. Now let's look at these results spatially. So the best way to do this is this tool actually produces maps for each of our outputs. And these maps are stored under our maps folder within our catalog. So we just have to, in your catalog, navigate to your maps and navigate to each of your change detection folders. So RSF max, risk, and habitat states. So let's start with our RSF max layer. And here it just shows you exactly where on the landscape our RSF has increased or decreased. Red would indicate a decrease, green would indicate an increase, and the different levels of colors indicate how much that increase or decrease occurred. Now looking at risk, very similar. However, the color palette is inverted. So a large increase in risk is actually indicated in red versus a reduction in risk, which would be indicated in green. Now let's look at habitat states. And again, the same thing. We have increase versus reduction. Reduction in this case would be an increase in sinks, whereas an increase is an increase in habitat. So primary and secondary habitat, whereas a reduction would be an increase in primary or secondary sinks. Another thing that is important to note is that all of your change detection runs will appear in the same map. So as you can see here, we have a change detection run 01. That's the most recent one. And then I have the one that I ran previously. So all of these will be grouped within each of these maps here. All right, so we ran all the tools. We ran our habitat states tool, our area plots tool, our change detection tool, and now comes arguably the most important portion of our presentation, which is interpreting the results. And firstly here, I just wanted to reiterate the goal in all of this, and that is to maintain as much primary habitat / high RSF areas while reducing the amount of new risk to grizzly bears. When we are interpreting our results, I think that one of the most useful tools is the change detection tool. And it's useful for determining exactly what the most significant changes are and where they occur between our scenarios. And the area plots enable this easy visualization and comparison of this change. And our spatial outputs allow us to determine where the most drastic changes occur on the landscape. I also want to go over what influences change within our outputs. So for RSF, distance to streams, soil wetness, forest regeneration, canopy cover, percent conifer, distance to forest edge, and land cover all influence changes in the output. For risk, terrain ruggedness, proximity to protected areas, distance to forest edge, distance to roads and trails, and land cover all influence the output. For habitat states, we combine RSF and risk, and therefore all of these variables influence the habitat state's output. I can't say whether each of these variables positively or negatively influences change because they change per BMA and per seasonal outputs sometimes. So different BMA and seasonal models will have different variable magnitude and positive or negative influence. So now let's take a look at how RSF, risk, and habitat states change over time. We're going to examine this change over time in the small study area in Bear Management Area 3, or the Yellowhead Bear Management Area, which lies between Hinton and Nordegg, or Highway 16 and Highway 11. First, I wanted to look at some satellite imagery outputs from Landsat in 2000 and 2018 that overlays our study area. So the first image here is from 2000, and you can see that on the landscape, there's a few cut blocks, some mining activity, obviously some roads. And now let's compare it to 2018, and we can see that there's quite a bit of new development, namely in mining and cut blocks within this area, as well as new roads. Okay, let's take a look at RSF from 2000 to 2021. In 2000, we see that we have fairly decent RSF in our core area here, namely around roads and around cut blocks. We also have poor RSF to the north and east here, but it looks fairly good. When we move to 2010, we see that we have a further increase in RSF, mainly due to the addition of new cut blocks, new roads, opening up new forests, and creating better food availability for grizzly bears and better grizzly bear habitat. We see a further increase in 2021 as industry and development increases further. So we're opening up more cut blocks, we're adding more openings on the landscape again, and creating higher RSF values on the landscape. Next, let's look at risk from 2000 to 2021. So as you can see here with the risk, we have risk around roads in our core area here. However, it's fairly low risk. The higher risk is to the north and east here. But if you recall from our previous slide, this area does not overlap with high RSF. So fairly good. Moving towards 2010 now, we see that we have increased risk. And this is due to the addition of more roads in our core area and more cut blocks in our core area. And yeah, we see that we have a high increase in risk. Moving towards 2021 now, we see an even larger increase in risk, whereas now we have almost high risk over most of the landscape, not just in our northeast portion here, and it's creeping into areas of high RSF. Now let's combine our RSF and risk outputs and look at them under the lens of the habitat states output from 2000 to 2021. Beginning with 2000, if you recall from RSF, we had high RSF in this area, in our core area here, and we had fairly low risk. And this reflects with this, being that now we see that we have fairly high amount of secondary habitat and a decent amount of primary habitat, while having a lower amount of primary sink and secondary sink. However, when we move to 2010, we see that we now have increased our primary and secondary sinks significantly in this area and reduced their secondary and primary habitat. And this is mainly due to the addition of cut blocks and new roads in this area. Moving towards 2021, relating this again to our RSF and risk layers, we saw that we had a high amount of RSF in 2021 in this area and also a very high amount of risk. Therefore, we now have a large primary sink with a fairly decent amount of secondary sink and very low secondary and primary habitat in this core area. Now let's look at this through the lens of our change detection plots. And we're going to do this for RSF, risk, and habitat states. In all of these scenarios, our reference is going to be considered our 2000 values, and our scenario is going to be considered our 2021 values. And our reference values are going to be in red, and our scenario values are going to be in green. Now, looking at RSF, we see that the biggest notable change is that we have, from 2000 to 2021, increased our RSF significantly in our high RSF values, up to 30% in our RSF 9 value. That being said, like we saw within our risk layers, we have significantly increased risk in these high risk values here. So from 7 to 10, up to almost 200% in our high risk 10 value, and almost 150% in our 8 and 9 values. Now, again, combining our RSF and risk outputs to create our habitat states output, we see again, as we saw in our layers, that we have increased our primary sink significantly, up to 73%. And we have also increased our secondary sink. We have at the same time reduced our secondary habitat and primary habitat significantly as well, up to 40% for our primary habitat. So we've looked at a small study area and we've seen what the impacts are over time for our habitat states. But now let's take a look at what a whole BMA is doing. For this exercise, we're going to look at BMA2 habitat states. And we're going to look at it from 2008, which was when our most recent population survey was done, to our most recent data in 2021. We chosen BMA2 because it is our largest BMA and has our densest bear population as shown in the population estimate in 2008. So over an entire BMA, again, we still see that we have an increase in primary sink and secondary sink and a decrease in secondary and primary habitat. When we look at the exact amount of change, we see that we have a 24% increase in primary sink and a 3% decrease in primary habitat. So while it's still there, we see that it is much less drastic when we look at an entire area. For this entire exercise of looking at change over time, I think it is important to note that when we do develop things, we're not going to avoid creating sinks and reducing habitat, but we need to be cognizant about how we do it, and we need to use these tools to do it strategically to lessen the impact overall. In terms of management, it is important to run these tools alongside our road density tools. And we need to ask ourselves, do road densities increase in these areas? And how do they affect our RSF and risk outputs? And whether regulating road access into these areas via gates or a road closure can in fact decrease our risk. The limiting factor in all of this is not our RSF, because as we saw in our small study area, RSF in fact increased quite a bit when we added new development, but we also saw a large increase in risk. Therefore, we believe that risk should be our primary focus because bears need to survive until 4 to reach sexual maturity. And the probability of survival to this age 4 goes down drastically on a risky landscape. Finally, I just wanted to touch on a few limitations to these tools. The first being that models are models and provide insights, but are not 100% accurate. Most of these models have been developed in the past and therefore may not be 100% accurate to these dates, but they do provide us with an overall insight into what is happening on the landscape. Another thing to note is that things like citability buffers alongside roads are not considered in these models. So these could, in fact, help and reduce risk on the landscape. But since we don't consider them in these models because we just consider proximity to roads, therefore, it is another tool that we could look at for limiting the risk on the landscape. All right. Well, thank you for listening. That's the end of our Habitat States webinar. And I hope that you've learned and maybe a little bit more knowledgeable surrounding our Habitat States toolset, namely RSF, risk, and habitat states, and also how to interpret them. And now we request something of you. We want your feedback. So we request that you report any bugs, any interpretation questions, what you would like to see future versions do, and let us know, did we miss anything within the webinars? And you can make those comments and feedback to the contact information in the webinar description. Thank you very much for listening.